All right. So today we're going to go through chapter 14 of Algernon Allen's Universal Economics. This also marks a transition from talking about the pricing and allocation of existing goods and into a discussion of who is going to produce what and how much they'll actually produce. So what we want to talk about first would be something we could call productive capabilities, or productive ability, I should say, versus cost of production. Now, let's suppose we have two different people. We'll name them Bill, and then we'll name one Susan. Bill can make up to 10 cakes per day, or he can make 5 jams. Susan, on the other hand, can make 15 cakes, or she can make 10 jams. Okay, and this is all in one day. And so these right here, these will be descriptions of their productive abilities. Okay, what we're talking about here is what they are actually capable of producing. Okay, so let's back up. Now, costs, if you recall from way back several videos ago, costs are all referred to, or are all deal with what we give up in order to do something. Remember, all costs are opportunity costs. And so the cost of making a cake in this example would be the jam that is not actually produced. Okay, and so if we have Bill making his 10 cakes, then he gives up making 5 jams. What we can also point out is that for Bill, 1 cake costs half of a jam. Or we could phrase this a different way. We could say 1 jam costs 2 cakes. Right? Every time Bill makes 1 jam, he gives up the opportunity to make 2 cakes. Susan, on the other hand, if we look at her numbers, it would be 1 cake costs 2/3 of a jam. And likewise, 1 jam costs 1.5 cakes. And the way we're getting these numbers is we're dividing the numbers over here by each other as appropriate. So 1 cake means if I take this number here and I divide it by 15, well, I'm going to take this number and also divide it by 15, right? And so 10 over 15 is the same thing as 2/3, okay? And when we were talking about Bill, we would take the 10, right, divide that by 10, that would be 1. We would take the 5, divide that by 10, and that would be 2. And that's how we got this half right here. Interestingly, notice that Susan is the most productive at both cakes and jam, right? Susan can make 15 cakes, Bill can only make 10. Susan can make 10 jams, Bill can only make 5. However, she is only the least cost producer of jam. So for Susan, 1 jam costs her 1.5 cakes, whereas for Bill, it costs him 2 cakes to make a jam. In other words, we could say that Susan gives up fewer cakes in order to produce jam than Bill does. Likewise, even though Bill is not as productive at producing cakes than Susan, he is still the least cost producer of cakes. Every cake costs him 1/2 of a jam, whereas it costs Susan 2/3 of a jam. So in other words, Bill gives up fewer jams to produce cake than Susan does. And so what I want you to notice is that because of how math works, it is impossible for anyone to be the least cost producer in everything. In fact, everyone is the least cost producer of something. And so one thing that a good college education should do is that it should help you discover what it is that you are the least cost producer of, and it should help you figure out how to utilize your intrinsic talents better so that you can be more productive and be more successful at whatever you define as success in life. Now, if you've taken a different economics course before, you've probably seen very similar things to this, and you've heard of them as absolute advantage and comparative advantage. And these are basically the same things here. Okay, so for Susan, Susan clearly had the absolute advantage in producing jams compared to Bill, because remember, if I put our 2 by 2 matrix up again, and if I can spell Susan correctly, okay, Bill, if we recall, could make 10 cakes per day. Susan could make 15, and Bill could make 5 jams in a day, and Susan could make 10. Okay, so in this example, Susan has the absolute advantage in producing jams compared to Bill because 10 is bigger than 5. And she also has the absolute advantage in producing cakes because 15 is bigger than 10. Comparative advantage compares the relative abilities of people at making goods relative to their opportunity costs. And so even though Bill is inferior in his ability to make cakes compared to Susan, he is superior to her in his what we could call relative ability to make cakes. Now, most non-economists focus on absolute advantage. Economists tend to focus on comparative advantage. Now, let's switch gears and we're going to talk about marginal and average costs. Now, marginal costs, often just abbreviated as MC, these are, just like any other time we talk about marginal anything, they refer to the added cost of producing one more unit of whatever it is that we're talking about. We can also think of it as the change in total cost. So for Bill, the marginal cost of producing each cake is half of a jam. For Susan, the marginal cost of producing each cake is 2/3 of a jam. The average cost, it's probably easiest just to explain this mathematically. The average cost is just going to be equal to the total cost divided by the quantity. Now, in the case of Bill and Susan, we're making three very powerful simplifying assumptions that we will change as we progress through here. Okay, so we're going to assume that there is no initial setup required. We're also going to assume that there are only two goods of interest, in this case, cake and jam. And then we're also going to assume that the marginal cost is constant, and therefore equal to average cost. Now, let's make a real quick mention of rate versus volume of production. Now, the rate refers to how quickly things are being produced. The volume, this refers to the total amount of work done. Or a better way to put it is the total amount of production that happened. As an example, I actually work at a pretty low rate, at least relative to some people. But I compensate for this by working more hours than a lot of people. Some people work very quickly and so can get the same amount of work done as I do in fewer hours. But at the end of the day, we both get the same amount of stuff done. Now, costs of production depend very much on the rate and volume of production in much the same way that the cost of travel depends on the speed and the distance that we travel. So if you want to travel a further distance, that's going to cost more money, or it's going to cost you more in terms of your opportunity cost. And if you want to travel that distance faster, well, it's going to cost you a lot more to do it. For example, we can look at the price of airline tickets versus the price of driving, just in terms of dollars, okay? Not in terms of opportunity cost here. Now, we don't typically confuse miles per hour and miles traveled in our minds. And so this distinction between the rate of something is kind of like the miles per hour, and the volume is kind of like the miles traveled. And so while this might sound tricky at first, it's really just the exact same concept of speed versus distance, if you want to think of it this way. Now, there are a couple of things to keep in mind, right? So, ceteris paribus, right, which is just our fancy way of saying all else being equal. First, the larger the volume, the higher the total cost will be. And second, the faster the rate, for a specified volume, I should say, the higher the total cost of producing for that volume. Okay, so now I'm going to put table 14.2 from page 201 up here, but I'm going to do it a little bit differently from the way the book does it. Okay, so I'm going to walk you through some of the other things first. Okay, so thank you for bearing with me while I wrote that out. Now, in the book, all of these columns here are filled in, but really, we should keep in mind that we're only actually given column 1, the output in cakes, column 5, the alternate product in Y in terms of dollars, and column 6, the marginal worth of cake. We can construct everything else in here from these 3 columns, okay? And so what the first column is saying is how many cakes is this person actually producing per day, and the number goes from 0 all the way up to 10. What this column, column 5, is saying is we can produce some alternative product Y, and we're going to measure the value of Y in terms of dollars. Okay, so in the case where they're making 0 cakes in a day, they can produce $13.50 worth of Y. Okay, and if they were to produce 1 cake, well, that would leave them enough time to produce $12.60 worth of whatever Y is. And then finally, this last column, the marginal worth of cake. What this column is showing us is how much is that cake worth? So in the case of the first cake, that first cake is worth $1.15 to, in this case, someone named Adam. Okay, and the second cake would be worth $1.05. The third cake would be worth 95 cents, and so on and so forth, right on down the line. Okay, now we see here that this person named Adam can make at most 10 cakes in a day. And so the question we might want to ask is, how many cakes will he make in a day given his opportunity cost and given his personal worth? So to calculate column 3, which would be the marginal cost, okay, what we need to do is look at changes in column 5 as we move down. Okay, so the very first cake that we make costs Adam $13.50 minus $12.60. And so what we should have, well, the first cake, or zero cake, that doesn't have a marginal cost. It also doesn't have a average cost, and it also doesn't have a total cost. So we can ignore that first column here, just like we did with the marginal worth of the 0th cake. That doesn't really make much sense. Okay, so to figure out the marginal cost of the first cake, we have to look at how much Y Adam is going to give up. So Adam is left with $12.60. He had $13.50. And so we can say that this is now going to be a marginal cost of 90 cents. And we can also look at our total cost, right? That would be $0.90. And our average cost would just be this 90 divided by the 1, which would give us 90 cents as well. For the second cake, if Adam were to be here and move down to the second cake here, whoops, too far, there we go. Adam is giving up $1 worth of whatever Y is. And so we can say that the marginal cost is going to be $1. The total cost, we would just sum the two marginal costs here. So the $1 plus the 90, that would be $1.90. And the average cost, as you can see, is going to go up to 95 cents because that is what $1.90 is divided by 2 cakes. Okay, for the third, right, we can see going down from $11.60 to $10.50. That means they give up $1.10. Okay, this changes the total cost to $3 and the average cost to $1. Okay, and we can repeat this all the way down. Okay, and I'll leave that to you to do on your own. Okay, and you can see the answers in the book as well. Now, so how many cakes will Adam actually produce, right? And this is where things get kind of interesting. Okay, so what we want to look at is the marginal cost of producing cake. So we want the marginal cost, and we also want the marginal personal worth. Now, like in everything else in economics, we want to equilibrate these, or at least get them as close as we can without the marginal cost exceeding the marginal worth. And so let's look at the first cake. The first cake has a marginal cost of 90 cents. It has a marginal personal worth of $1.15. And so Adam will definitely make the first cake. For the second cake, it has a marginal cost of $1. It has a marginal worth of $1.05. So Adam will definitely make the second cake. And for the third cake, it has a marginal cost of $1.10 and a marginal personal worth of 95 cents. And so Adam will not make the third cake. And if we assume that Adam cannot produce a fraction of a cake, then Adam's going to stop producing at 2 cakes. Now, one question we might ask is, why are the marginal costs higher at faster rates of production? And really, there's 2 main reasons. So first In order to produce more per day, it's often the case that more equipment and more people are used. So one, more people and more equipment. Now, this equipment, this additional equipment, is often seen as reserve equipment that is only used for times when increased production is necessary and is often on reserve because it's just not as good as the more commonly used equipment. Also, if you're going to be hiring more people, for example, temp workers, these people are not typically as good as your main workers, and so they'll produce less per day than your typical workers. However, they're still worth hiring because they increase the rate of production. They just cost more per unit produced because they're not as productive as sort of your main team or your main set of equipment. The second is a standard thing in economics called diminishing marginal returns. Now, this is a law in economics. As more units of one of the resources being used are added to a fixed amount of other inputs, the marginal returns with the additional units will, beyond some amount of that kind of resource, begin to decrease. And there are no exceptions to this. Now, this law sounds way more complicated than it actually is. And the idea here is a very simple one. So, beyond some point, the marginal productivity of a resource must decline. And this is an easy one to think about, perhaps in the context of fertilizer and plants. So if you have a plant and you add fertilizer to it, it will grow. If you add more fertilizer, it will probably grow a bit more, but less than it did before. In other words, you can't just keep adding fertilizer and grow an infinitely tall plant in a single pot. Or, if you don't like that analogy, think of watering the plant. Is some water better than zero water? Well, of course it is. But it's not like you can literally flood a plant with water and expect it to grow to 1,000 feet tall. Now, if you gave the plant more water and more fertilizer and more room to grow, then sure, you can get back to increasing marginal returns. However, there you would be relaxing multiple constraints, not just one. Now, if you could actually grow an infinitely tall plant in a single pot, this would be great. We could grow all of the food we would ever need in a small potted plant. Clearly, this is not how biology works, and it also applies to production and people as well. Finally, we want to look at the price of labor versus the cost of output. Now, many people bemoan the low wages that are paid in some foreign countries and call them exploitative in some way. Now, to be sure, there almost certainly are some circumstances that are actually exploitative. And if you're interested in talking about these or learning more about these types of scenarios, you should look at the link to the video in the description below by a guy named Ben Powell, who has written a book about this. In situations that are not exploitative, though, we can start to understand things. Now, the relationship, if we wanted to relate the price of labor and the cost of output, the relationship is actually relatively simple. The labor cost of production is going to be equal to the wages paid per hour divided by the product per hour. Or if you want to simplify, since we can get rid of these things here, it's just going to be wages divided by product. So let's suppose that a worker in the US, right, so US earns $20 per hour, And in that hour, they are able to produce 10 units of some product, whatever this is. A worker in a different country, which we'll just call a foreign country, might get paid, let's say, $10 per hour and only produce 3 units of some product. So the US worker's labor cost per unit of output is equal to 2 or $2. The foreign workers is equal to $3.33. And so even though the US worker is more expensive in terms of wages, in fact, they're twice as expensive in terms of wages, they're actually less expensive in terms of their labor cost per unit of output. Now, what would happen in this market if these numbers were actually true? Well, we would see US workers get employed. Okay, now this would increase the demand for their services, which would actually act to increase their wages, but also increase their labor cost per unit of output. We would also see the demand for foreign labor actually decrease, which would decrease their wages and also decrease their labor cost per unit of output. And this would continue until the labor costs of production are actually equilibrated. This is one of the pernicious side effects, or what economists call unintended consequences, of trying to force companies to pay their foreign workers more money. The result is a decrease in demand for those workers and an increase in demand for US workers. And so, this is one of the dangers of trying to run around the world and set prices correct, quote unquote, because it could end up making many, many things much worse.